Hello, I'm Alan Thomson. I'm the Technical Director here at Rivet Games, and I'm responsible for, amongst other things, the track and infrastructure and signalling tasks that we use when we develop a route. My background's quite interesting in that I actually started work as a railway photographer in British Rail, doing everything from PR photography, so it could be photographing an opening ceremony one day, to working on engineering projects. It gave me a lot of knowledge about the industry, how the engineering side of the railways operate in the UK. And then about 15 years ago, Train Simulator, as it was being developed in the early days, sparked my interest. And since then, I've been working in Train Simulator and developing routes all around the world. What I'd like to do today is to show you some of the technical input that goes into route production. And on screen just now, this is the Gotthardbahn route that we're developing in Switzerland. The different track types that we can allocate to track can be illustrated if I just tab through this with the spacebar. Main line track is shown in yellow, and yard track is shown in brown. This is quite important to get right for scenario development. So where we have an AI train that's going to find its way to a particular location, we need to make sure a passenger train follows the correct lines. We don't have it going into a yard, back out of a yard, back onto the main line. We've got a location that perhaps there's one track that's unidirectional, we can apply that, and you would see that in red. However, in this location, all tracks are bi-directional. We can also go into the next view, which shows speed limits. The yellow in this instance shows 40 kilometres an hour. Then we have some track at 60 kilometres an hour in blue. But you'll notice on this particular track, there's actually two different speeds. The primary speed limit is 80 kilometres an hour, and secondary is 70. Secondary speed limits are used for freight trains rather than passenger trains. In reality, you can sometimes have 4, 5, 6 different types of speed limits dependent upon traffic. When we come to signalling the route, so in simple terms you can think of them as traffic lights. However, that is a major simplification. So you get speed-based signalling systems, you get block signalling systems. The system you're looking at on screen just now is actually the L-type system in Switzerland. The L-type system is a speed-based signalling system that shows different combinations of lamps to communicate to the driver a number of things. If you get an indication as shown here, this is giving you pre-warning what the next signal is going to be showing you. So there's a lot of research goes into these different signalling systems. We need to script these, we need to make sure they simulate as much as we can the real systems that the railway uses, but we also want to make the system fun, we want to make it enjoyable for players. So if we choose this signal, for instance, when I click this in the editor, we have different links, and the links are positioned on the track. The first link is the logical link for this particular signal, and this is the point at which you mustn't pass if the signal's at red. Beyond that, we have two additional links. These are located beyond the last junction out of the station, and there's little numbers above these, so we've got a number 1 and a number 2. This signal here, for instance, has 5 different links. The first link again at the logical position for the signal, and then as we move forward there's 4 links. You've got a link into this siding that goes inside this little depot building. We've got a short siding here, and then we've got again the 2 links to go into the main line. Another technique we use for developing track and signalling assets is to use what's called a sandbox route. The good thing with the sandbox is you can see all the different types that we've been creating and testing. This is also all the different track types that we use on the current route. Some of these being meter gauge, some of them being standard gauge. Here we have new ballast that's been applied to the track. This is wooden sleepered, this is concrete sleepered track. So there's lots of different types. We've got some that have integrated tunnels, and also the method of laying track can be tested here as well. This area, for instance, we have a different number of curvatures here which illustrate what's called super elevation. Super elevation is a kind of fancy term to explain banking of a curve. This area of the Gotthardbahn is a place called Bodio. This is quite a good place to look at track gradients. Track gradients is another key aspect of what we do with track installation for a route. We need to look at getting very accurate track data. We need to get reference for what gradient, what slope the track is at any given point in a route. If we get it wrong, then we can end up with a track that ends up floating into mid-air when it should be on the ground. Or alternatively, it might bury itself into cutting where there's actually no cutting in reality. You can see this collection of yellow arrows pointing up This is actually a transition from level to a set gradient. So if we go beyond these yellow markers and look at the track and hover over it, we can see it's actually saying 10 per mil. So this is actually a 1% increasing gradient. As we come up, we can see there's another collection of markers in the track, and go beyond there, and we can see this is now 16 in 1,000, or 1.6% increasing gradient. When gradients do align with the landscape, it's very obvious, and certainly on mountainous routes like this, you learn very, very quickly if something has gone wrong. But certainly we need to make sure we keep synchronisation all the way from one end of the route to the other. Gradients are probably one of the most tricky things to get right in Train Simulator, but getting them right is key to make sure the experience of driving the train is accurate and it feels like the actual route that you're trying to simulate.